Hello middle one and welcome to another video. In this video we will talk about the chemical symbols of some elements. Some elements have more than two letters. As a symbol, that is because the first letter was common in these elements. Such as we have the calcium, so we have the calcium. The calcium, we can't use a capital C. That's why, because it actually used by the carbon. So if we look at the carbon symbol is capital C. If we take the capital for the calcium, it will be the same element. So we choose that, or all the scientists choose that to take the first two letters of the calcium as its symbol. Also we have the helium. Where is the helium? This is the helium. Helium, we can't use a capital H. Why? Because we have the hydrogen with capital H as a symbol for it. So we choose to take the first two letters from the helium. Also we have the nickel, and the sodium has the same problem. But where is this name come from? And why the symbol of sodium, for example, if the sodium is a sodium, the symbol like that. Alright, this is because some elements are not taken from English, but taken from Latin language, which are of different letter. So the Latin language have different letters from the English language. For example, we have the sodium. The sodium take the symbol Na, N capital, A small. This is because of the name of the sodium in the Latin language is natrium. So it began with Na. So we take Na as a symbol for sodium. Also we have the potassium. The potassium symbol is K, and capital K come from the Latin language of the kalium. Okay, then let's go into take a quick recap on the atomic structure. Inside the nucleus in the atom, you have protons and neutrons, and the protons take the positive charge and neutrons and as a neutral charge or has no charge at all. And it actually locates in the center of the atom. So at the center of the atom as the simplest type or the fundamental unit of any matter, have the nucleus in the center of the atom that consists of or include the neutrons and protons. Neutron and protons. And also we have the electrons that placed in shells or energy levels, and the number of energy levels in the heaviest atom or the maximum number of energy levels will be 7 energy levels. So let's look at this diagram that show the positively charged nucleus in the center of the atom surrounded by the energy levels. Okay, this is the time for a little track to be sure and differentiate between the atomic number and the atomic mass that may be replaced their places from below to above according to the type of table, so don't worry. Once we can find the atomic number below the symbol, and it might find above the symbol or the element, but we take that for granted. The atomic number is usually that's smaller than the atomic mass. So Usually the atomic number is smaller than the other number that named by the atomic mass. That's why, or that's because, the atomic mass is the summation of protons, or the summation of the number of protons and neutrons together. But the atomic number is the number of protons only, or the number of electrons that equal to the proton. So we will take this example to be sure that we can solve any problem that include getting or measuring the atomic mass, or the number of protons, or number of neutrons, or even the atomic number. Okay, how to calculate the neutrons numbers? For example, we have the oxygen. The oxygen mass number is 16 and the atomic number is 8. How we can get the neutron number? We can get the neutrons number by knowing that the atomic number, this atomic number, is the number of electrons, or, and focus, its number of electron or the number of protons inside the nucleus. Okay, so this 8 is the number of proton, and we have the mass number, mean that the mass number subtract from the number of proton, so we can get the number of neutrons. Okay, as far we have 8 as a number of electrons or protons or atomic number, and the other, or the biggest number that's bigger than the atomic number, the number of, yes, proton and neutron together, as a mass number.